Okay, we're back with example 4. A rectangular building lot is 8 feet longer than it is wide and has an area of 2,900 square feet. Find the dimensions of the lot. So it's asking you for the dimensions. You need width and length. Pick one to go with, it doesn't matter. I'm going to say, hey, I'm trying to find my width. I'm going to call it W. Of course, you could call it X. And if that's my width, then my length is 8 feet longer than it is wide. So it's 8 feet more than the width is the length. And I know the area is 2,900. Well, the area formula for a rectangle is length times width. Or in this case, the length is W plus 8 times, the width, which is W. And you know that area is the 2,900 square feet. So now, in order to solve, because I can't just split these up and set these factors equal, you can only do that when it's 0. So I'm going to distribute on the right. Still not going to be able to factor this or do anything from here until I get it equal to 0. Now you can factor, you can quadratic formula. What I want you to do right now is pause it and solve for W. Okay, hopefully you paused it, you've already solved for W and you're checking back in, and it would have factored into -50 and a positive 58, or you would have done quadratic formula. Either way, you should have found that you have two options for your width, either 50 or -58. Now you got to figure out which one it is. Common sense will tell you you can't have a negative width. So this one, it is a solution. It's not an extraneous solution. It's a solution. It just doesn't work in our application here. And so this is what we want, but remember the original problem asked for dimensions. So we'll answer in two ways. We'll say the width of the lot is 50, but I have to include units. Remember the area was in square feet, so 50 feet. And then the length of the lot is 50 plus 8, 58 feet. And that will answer that question. Example 5. A man 6 feet tall wishes to find the height of a certain 4-story building. He measures its shadow and finds it to be 28 feet long, while his own shadow is 3.5 feet long. How tall is the building? Okay, so what you have here is you can kind of picture a 6 foot tall man and a building. So here's the man, here's the building. They're not the same height, even though they look like it. Okay, whatever. The model doesn't actually have to have pictures with it. But he's 6 feet tall. We don't know how tall this building is. We know it's 4 stories. So if you know a little bit, you know a story is it's normally somewhere between like 10 and 12 feet is how high a story is. So that kind of gives you a frame for reference. He measures its shadow, this being the building, and finds it to be, so this is its shadow, 28 feet long. His own shadow is 3.5 feet long. And what we don't know is the height of the building. I'm going to call it H for height because that's what I'm looking for. You can solve you can try solving using right triangles. This is a typical right triangle problem that we see. But you have two different things going on, so you can just set up a proportion. Assuming he took these measurements at the same time, which we are based off the information he gave us, because it says while his own shadow. So it's at the same time. The sun's at the same place, has the same angle down, so we can just set up a proportion. If he is 6 feet tall and his shadow is 3.5 feet long, the height of the building is however tall over its shadow. And you can cross multiply and solve, and when you do, you get 48. And so how tall is the building? It is 48 feet tall. Okay, don't forget, email me with questions. Definitely pause it, try to work it out on your own, make sure you're not just copying my notes blindly. That's not going to help you in any way, and we'll know that come homework time. Example 6. This is kind of a more detailed problem, but I'll go ahead and tell you I really like this problem. I think it's a really good problem. A manufacturer of soft drinks, which by the way you totally shouldn't drink, those are unhealthy for you, advertises their orange soda as naturally flavored, although it contains only 5% orange juice. A new federal regulation stipulates that in order to be called natural, a drink must contain at least 10% fruit juice. How much pure orange juice must this manufacturer add to 900 gallons of orange soda to conform to this new regulation? Now, it sounds like a picture would be hard here, but I think it'll help. So, if you've taken chemistry, which I think you all should have, then you've done something like this with solutions, and it's pretty much the same thing. I'm going to say here we have the 5% juice. So this was the like original OJ. And the goal is it's going to have to be 10% OJ. And we're going to add to it pure OJ, which is going to be 100% juice. And so here's kind of a picture to help. And then what we want to solve for is, well, how much pure orange juice? So what I'm looking for, my X here, is the amount of 100% OJ that needs to be added, and that answer is going to be in gallons because this is 900 gallons. Now I can fill in some of the other information I know, which is that we do have this 900 gallons of the orange soda, which was the original. So I had 900 gallons. I'm going to add some amount of OJ. How much is that? Well, that was my X. We don't know. And so when I do, I of course get 900 plus X for the total amount of juice. It's going to have that original 900 gallons and however many more gallons that I add. Okay, so that's kind of just my, I'm going to say volume of juice. Right, that's how many gallons I have, but I have this 5%, 100%, and 10% that helps us. Oh no. I have my 5%, 100%, and 10% that does help us, and that's the actual amount, not of like juice, but of the pure OJ or how much percentage OJ it is. And so you have 5% of 900 gallons, 0.05 times 900. And then here you have 100, so that's 1, right, times X. And then here you have it's going to be 10% of this. So all I did there was multiply the percent times the amount to get the amount of pure OJ in there. Okay, sorry, now we're good. I got plugged in. Okay, so now we're going to take this equation we wrote in blue and we can solve for X. So 0.05 of 900 is 45. 1 times X is X. And then if you want to distribute 900 times 0.1 is 90 plus 0.1 X. Now you just need to solve for X, get your X's on one side. So I'm going to subtract. So I have 1 minus 0.1x, which is 0.9x or 0.9x. And then 90 minus 45 is 45. Now divide by 0.9. I get x to be 50. Go back up, read the question. How much pure orange juice must this manufacturer add to 900 gallons of orange soda to conform to the new regulations? Well, they have to add 50 gallons. We should include units. So they need to add 50 gallons of pure OJ to conform to this new regulation. Awesome. Okay. Example 7. Because of an anticipated heavy rainstorm, the water level in a reservoir must be lowered by 1 foot. Opening spillway A, so we have two different things going here. A lowers the level by this amount in 4 hours, whereas B does the job in 6 hours. How long will it take to lower the water level by 1 foot if both spillways are open? Okay, so the first thing like always we do is define our variable. I'm gonna pick x again. You can do t for time or whatever, but it's how long it will take to, so it's how long, so it's time, right? To lower water 1 foot if spillway A and spillway B are open. That's kind of a long variable, but we got to make sure we include all of that. It's all really important. Okay, so there's a few things we know. We know that we're trying to find the time it takes, right? That's our x. We know the distance A lowers. So A was what I underlined in yellow. It is going to lower it in 4 hours. So the time it will take for A to lower it would be 4 hours, and the time it'll take for B to lower is 6 hours. 6 hours. But we need to write it in terms of distance instead of time. And so if it takes 4 hours for it to lower 1 foot, its distance is 1 foot. 1 foot per 4 hours is, so the distance is 1 foot per 4 hours, or 1/4 foot is how long it lowers in 1 hour. So how much it lowers in 1 hour for A, we're going to do the same thing for B. So if it was 6 hours for 1 foot, it's 1/6 foot is the distance it will take for it to lower in 1 hour for B. Okay, but we need to know the actual distance. Distance, but we need to know the distance of both of them. Sorry. And again, it's, right, we had 4, 1 over 4, 6, 1 over 6. So x was how long it was going to take for both. So 1 over x be the distance in 1 hour for both being open. Now we can set up our model. So we know that however much work is done by A plus however much work is done by B is how much it's going to take for A plus B to be done. And then the easiest thing to do here is going to be to, well, you can find a common denominator and you can add, but to get rid of some of these fractions, we can just multiply through. I would multiply through, I see this has a 4 and a 6, so their LCD here is 12. So I'm going to multiply both sides by 12. And we get 12 over 4, which is 3. And then 12 over 6, which is 2. And 12 over x. Well, that's still not extremely helpful. If you want to go ahead and multiply through by x, you can, or we can combine here. 5 equals 12 over x, multiply both sides by x now if you haven't already. And you get 5x equals 12, or x equals 12 plus. Now scroll back up and it says, how long will it take to lower the water level by 1 foot if both spillways are open? Well, it'll take 12 fists. Yeah, but it was time in hours. So why don't you convert that to a fraction? It would take 2 and 2/5 hours, or 2/5 of an hour. We really want that in minutes, right? Which is 24. So you could either say it's going to take 2 and 2/5 hours. The better answer would be 2 hours and 24 minutes. So that's a lot better than waiting on the 6 hours or the 4 hours. We can just open both at the same time. Okay, I'm going to pause this and make the last video with the last two.